Hi everyone, it's Miss Sneer, and in this ed puzzle we are going to be starting stoichiometry. So stoichiometry is a fancy sounding word, but basically all it is combining what we've been doing with balancing chemical reactions. So the definition of stoichiometry is calculating the amount of a substance using a balanced chemical reaction. So far I've been giving you random stuff like if you have this many grams of this, how many moles of this, or whatever. And now we're going to think a little bit more in terms of a chemical reaction. So we're saying we start a chemical reaction with this much as a reactant, and we end with this much as a product. And we want to be able to go back and forth between those using the skills that we have already began starting. So let's start learning how to do stoichiometry. So first thing we're going to do is with mole ratios, which these are kind of familiar. But the difference is that when we do a mole ratio with stoichiometry and a balanced equation, we're going to use the coefficients. So we're going to use these numbers, there's an invisible one here, instead of these numbers, okay? So our question here is, how many moles of H2 were used if 6 moles of NH3 were produced? So H2 was one of our reactants and NH3 was one of our products. So we're saying that this reaction produced 6 moles of NH3, and we want to know how many moles of H2 were used up that went through the chemical reaction. So we're starting with, here, moles of NH3. That's the unit we're starting with, even though it's a product. And we're ending with moles of H2. So we already know that when we're going from moles of one thing to moles of another, we're using a mole ratio. This is something that we've been doing. And I'm going to do the exact same thing that I've been doing. 6 moles NH3, that's my start. Multiplying it by a conversion factor. Now here, our mole ratio is going to be just a little bit different. Just a little tiny bit different. So still, we want to put moles of NH3 on the bottom because we want to cancel that unit. But now we're going to use our coefficients. So we're going to say for every 2 moles of NH3 that there are 3 moles of H2. This would be the same thing as saying to make 1 cheeseburger, we need 2 pieces of cheese. So for every 1 burger, 2 slices of cheese. If we wrote like a chemical reaction, we could say like 1 patty plus 2 cheese plus, 1 bun is equal to 1 cheeseburger. Same sort of thing here. We're saying that for every 2 moles of NH3, there's 3 moles of hydrogen. And then we do the same thing where we just end up canceling out units. Moles of NH3, we're left with moles of H2. Multiply everything on the top, 6 times 3 is 18, divide by 2, that gives us moles of H2. Here it would be 9 moles of H2. Let's take a look at another example, same sort of thing. Our question here reads, how many moles of CO2 will be produced if we begin with 6 moles of O2? So again, we are dealing with moles of CO2, moles of O2. So we're still going to use a mole ratio here, going moles to moles. We're starting with 6 moles of O2, and we're trying to figure out moles of CO2. So I'm going to start with 6 moles of O2, and our conversion factor is going to be our mole ratio. Again, for our mole ratio here with stoichiometry, we're getting it directly from the chemical equation. So here, we need to put moles of O2 on the bottom in order to cancel. And I'm going to put 2 moles of O2 on the bottom and 1 mole of CO2 on the top. Remember, if there's nothing in front of it, that just means that there is an invisible 1. Now I can cancel out my units. Moles of O2, cancel those out. Now we're at moles of CO2. Do the exact same thing as I've been doing. 6 times 1 divided by 2 gives us 3 moles of CO2. What that means is that if we began this chemical reaction with 6 moles of oxygen, we would predict that we would produce 3 moles of CO2. This is the reason that we are learning how to do this, so that we can predict what will happen during a chemical reaction. So just to recap so far, in stoichiometry, when we are going from moles to moles with a balanced equation, our mole ratio is the coefficient from the equation of moles A and the coefficient from the equation of moles B. So like from our previous one, we said 1 mole of CO2 for every 2 moles of O2. And those came just directly from the balanced chemical equation. So let's take a look at another example. And I'm going to have you kind of try this one. How many moles of H2O were produced if we begin with 10 moles of CH4? So we started a chemical reaction with 10 moles of CH4. We want to know how many moles of H2O are going to be produced. So mole to mole, again, mole ratio. So let's go ahead and start our setup here. So I'm starting with 10 moles of CH4. Now our conversion factor is again going to be our mole ratio. What needs to go on the bottom? On the bottom, we're going to go ahead and put moles of CH4, just like we've been doing. And in the chemical equation, there's nothing in front, which means it's just 1 mole of CH4. And then on top, we're going to put 2 moles of H2O. Can cancel our units, mole CH4, left with moles of H2O. Now we can just do 10 times 2 divided by 1 is equal to 20 moles of H2O. So if we did a chemical reaction starting with 10 moles of CH4, which is methane, we would produce 20 moles of water, 20 moles of H2O. Continuing on with stoichiometry, we can also do this with all of the other conversion factors that we have been learning about. So for example, let's do this one. How many grams of CO2 were produced if we started the reaction with 8 moles of CH4? So this 8 moles of CH4, this is what we're starting with. So we're starting with moles of CH4, and we want to end with the mass of CO2. Just like we've been doing, we can take a look at this and decide what conversion factors might we use for this. I'm saying that we're starting with moles of CH4, and we need to end with mass of CO2. That means we're going to first have to use a mole ratio, then a molar mass. So this is going to be 2 steps. So let's start mapping this out. If we start with our 8 moles of CH4, let's get it to moles of CO2 using what we have been doing the past couple examples. I take a look at my equation. I see this has nothing in front, so that means it's just 1 mole CH4. And my CO2 also has nothing in front, so that's just going to be 1 mole of CO2. So now this is our mole ratio. And we're going to cancel our units. Mole CH4, mole CH4. Now we're at moles of CO2. How can we get from moles of CO2 to mass of CO2? We can go ahead and do 1 mole of CO2. So if we use molar mass, get that from the periodic table, this will be the mass of C plus 2 times the mass of oxygen. And this will end up giving us 44.01 grams per mole. Remember, just coming from the periodic table. So I can go ahead and put 44.01 grams CO2 on the top, cancel out mole CO2, and now I'm at my final thing. All you would then do is do 8 times 44.01 divided by 1, and that gives you grams of CO2. Since we're dealing with simpler numbers now, I do actually want you to go ahead and do the calculation to get an actual number at the end. So for example, this one here would be 352 grams of CO2. And that would be our final answer here. So we can use this stoichiometry with a balanced equation to predict what is going to happen for any chemical equation. We can do it for grams, we can do it for moles, we can do it for molecules and atoms if we want to. We're just going to combine some different skills that we have learned now.